The last part in this section is something called polymers. Polymers is one product of organic reactions. What is the meaning of polymers? Polymers are large molecules, very large molecules, made of many small units, joined to each other through organic reactions. So many small units, and then they are joined together through organic reaction. This gives us a large molecules, which is called polymers. The small units are called monomers. So, small units, monomers, are joined together through organic reactions to give large molecules, which are called polymers. Like this. If we have small units or monomers, small units of ethene, 2 carbon atoms and double bond, 2 carbon atoms and a double bond, and so on. And we are going to join these small units or these monomers together through breaking the double bond. So we're gonna break the double bond and connect them together, break the double bond and connect them together, and so on and so on and so on. And maybe it's 3 ethene molecules or 4 or 5 or 6 and so on. So the number of monomers or the small units can be hundreds or thousands, any number. Then we are going to join them together to give the polymer. So the small units are the monomers, and we are going to join them together to give a very large molecule, which is the polymer. Polymers can be made from identical or different monomers. So the monomers can be all one thing, identical, like the example in the previous slide, or different monomers. If the monomers were different, the polymer made from 2 or more different monomers is called copolymer, like this. If the monomers are all identical, like the example from the previous slide, is called homopolymer. But if the monomers different, not identical, like this, it's called copolymers. Polymers are all around us. In the food we eat, in the clothes we wear, they are all made of polymers. So we have 2 types of polymers. Natural polymers, like starch, cellulose, and proteins, or synthetic polymers, which is plastics, synthetic polymers like polypropylene. So we have 2 ways to form polymers. So like we said, polymers is monomers joined together through organic reactions. So we have 2 ways to join the monomers. The first way is by an addition reaction. Addition reaction, which makes the polymer addition polymer. So the addition polymer is a polymer formed by addition reactions between monomers that contain a double bond. Like we said before, the addition reaction must happen between unsaturated molecules. So the addition polymer is formed between monomers that contain a double bond. An example for that is molecules of ethene can polymerize with each other to form polyethylene, commonly used and commonly called polyethylene. Like this, ethene and N, which means any number of ethene. We are going to break the double bond, addition reaction, and we are going to connect the ethene to the next ethene, to the right next ethene, and so on. So the letter N showed that the addition reaction can be repeated multiple times to form a polymer of N monomers long. So if we have N or 5 ethenes, the polymer will be consisting of 5 long ethenes. If it's 100 ethene, the polymer will consist of 100 long ethene. In fact, this reaction can be repeated hundreds or thousands. So, addition polymers have many forms, have various forms. So, various forms of polyethylene have different molecular structure. Polyethylene, which has the monomer ethene or ethylene, repeated in different numbers. For an example, high density polyethylene, high density polyethylene, or HDPE, is a linear polymer and has a high density because the linear molecules can pack together closely. High density polyethylene, which is a very long chain of polyethylene, just a long chain, which is linear, no branches or anything. Ethylene and another ethylene and another ethylene. Ethylene is ethene, right next to each other. So it's a high density because linear molecules can pack together, we can crowd it together. So it's called high density polyethylene, HDPE. HDPE is used in plastic containers, such as milk and juice bottles. The milk bottle or the juice bottles we see every day is made of HDPE because it has a high density, so it tends to remain stiff and rigid, so we can put liquids inside. Another example of polyethylene polymer, the branched polyethylene. It's a long chain of polyethylene, but it has branches. The long chain has branches, so the branches of branched polyethylene keeps the molecule from packing tightly. We can't crowd it together because of the branches from the polyethylene, so it will have a low density. So low density polyethylene, low density polyethylene, or LDPE, have a low density, so it's used in plastic shopping bags. The shopping bags that is made of plastic is actually low density polyethylene or LDPE. Sometimes the chain or the long chain of polyethylene has cross atoms between them, so it's cross-linked polyethylene or CPE. The cross links make it very strong. The cross that connect the long chains together make it very, very strong, so we can make plastic crates out of it. So HDPE, which is linear, long chain of ethylene, linear, high density polyethylene, it's used in plastic bottles for juice or milk. Then LDPE, long chain with branches, low density polyethylene. We can use it in plastic bags. Then two chains and a cross-linked. They are linked with atoms. So this is CPE. The cross links make it very strong, so we can use it in plastic crates. So the second way to form a polymer is through condensation reaction. So it will give us a condensation polymer. The first way to form a polymer was through an addition reaction, which gave us the addition polymer. And the second way to form a polymer is through a condensation reaction, which will give us a polymer, a condensation polymer. So the condensation polymer is a polymer formed by condensation reaction. And the monomers in the condensation polymer must contain two functional groups. Each monomer must contain two functional groups. This allows each monomer to link with two other monomers by condensation reaction. Each monomer will link with two monomers. So each monomer must contain two functional groups. The condensation polymers are usually copolymers with two monomers in an alternating order. It's copolymers, which means it consists of two different monomers. What does all of this mean? So in this example, we have two monomers, two different monomers. The first monomer is a diacid. Diacid, which means it's an organic acid, contains two carboxyl groups. So the first monomer contains two functional groups, a carboxyl group and another carboxyl group, COOH, COOH. And the second monomer is a diamine. Diamine, which means it's an amine, but contains two functional groups, NH2 and another NH2. So each monomer contains two functional groups. The first is diacid, contains two carboxyl groups. And the second monomer is a diamine, which contains two functional groups, which is the amine group. How a polymer is formed between these two? By a condensation reaction, by removing a hydrogen from the amine and a hydroxyl group from the carboxylic acid or the carboxyl group, and it will form water, and the rest of the compound will connect or combine with the rest of the amine. So removing a hydrogen from the amine and removing a hydroxide from the other amine. So this is the link. Why each monomer must contain two functional groups? This is a diacid. The first carboxyl group formed a water with this amine, and the second carboxyl group will form a link with another amine here. And this amine is going to form another water molecule, another link with another acid here. So each one will connect to two monomers. This one is going to connect with amine from this side and another amine from this side through the hydroxide and the hydroxide. And this diamine will link to two other monomers, an acid from this side through this hydrogen and another acid from this side with hydrogen, and so on and so on and so on to give the long polymer. Another example for condensation polymer is acid, diacid. It must contain two functional groups, two carboxylic groups, and a dialcohol, which contains two alcohols. The hydroxide group from the carboxylic acid and the hydrogen from the alcohol, and they will link to form water molecule. And also the acid will form a link with alcohol from this side and another alcohol from this side. And the alcohol will form a link with an acid from this side and another acid from the other side, and so on. Another very important condensation polymer is a polymer formed between a carboxylic acid with two carboxyl groups, adipic acid. So adipic acid is a carboxylic acid with two functional groups, which is two carboxyl groups, and an amine with two amine groups, which is called hexanediamine. So hexanediamine is an amine with two functional groups, which is two amine groups. React with each other and form a water molecule, like this. It looks scary, but let's take a look. This is the hexanediamine. Hexan, which means 6 carbon atoms. 1, 2, 3, 4, 5, 6. So 6 carbon atoms. 1, 2, 3, 4, 5, 6. This is the hexane. And diamine, which means it contains two amine groups, 1 and 2, NH2, NH2, with a carboxylic acid with two carboxyl groups. a carboxylic acid which is also contains 6 carbons, but the carbons in the carboxyl group is numbered. So we have 1, 2, 3, 4 and COOH 5 and another COOH 6. So 4 carbons and a carboxyl group and a carboxyl group which makes it 6 carbon. It's going to combine or condense together. The hydroxide is from the carboxyl group, the hydroxide OH from the carboxyl group, and the hydrogen from the amine. They are going to link here and lose a water molecule. This process is repeated more than one time. At this compound formed after the combining of the two molecules is called nylon 66. So the products contain 2 kinds of monomers. The acid, which is here, and the hexane diamine monomer, which is here. This is a copolymer because it consists of 2 different monomers and is called nylon 66. Why 66? Because each monomer contains 6 carbon atoms. The hexane diamine 1, 2, 3, 4, 5, 6. And here 1, 2, 3, 4, 5, 6. We count the carbons in the carboxyl group. So the hexane diamine with adipic acid give us nylon 66 and water molecule. So the nylon 66 is one of the most widely used of all synthetic polymers. Nylon 66 is used in making of plastics and synthetic fibers like this: sleeping bags, rope, seat belts, hoses, dental floss, and all the cloth that is made of the synthetic fiber.